Well, hello guys, here Mr. G with another video. This time we're going to go all the way back to do another question on stoichiometric. It's a very important topic and children or learners attempt to forget, and you're going to need it throughout the whole year. As from now will be questions on stoichiometric, and this is across all grades, grade 10, 11 and 12. The balance equation for the formation between calcium and hydrochloric acid is given, and you have a chemical reaction there. 2,5 grams of calcium was reacted with 500 centimeter cubic of 0,32 mole per cubic decimeter hydrochloric acid aqueous solution. Now, show by calculation which reactant is the excess and by how much. So we need to know which one is excess and also the limiting reagent. By knowing the limiting reagent, we know which one is in excess. This one is not a big problem. So let's do question 8 real fast here. Now, what do we know? We know that for calcium was the mass of calcium now. So I'm going to write here for calcium separated, and I'm going to want to know what we have. Mass is equal to 2,5 grams. If we go to the periodic table, we know that the molar mass or atomic mass for calcium is going to be 40 grams per mole. Now guys, all the time when you are identifying the limiting or excess reagent, you need to calculate the number of mole of the reactant. So this one is going to be question mark. We don't know the number of mole of calcium. We have to calculate the number mole of calcium. Now, what formula are we going to use here? We're going to go and say the number of mole is equal to mass divided by molar mass. When you substitute, you have that is 2,5 divided by 40. And then this one is going to be 0,0625 mole. That is the answer. You know what? I'm going to take it from there and move it down because I want to work on this side like that. Okay, so that is for calcium. Now we have to do the same for the other reactant, which is the hydrochloric acid. So I'm going to write here very organized for HCl, and everything I'm going to do here is for HCl. Now what do I have? I have the volume, which is 500 cubic centimeters. Note and remember, you cannot work in centimeter cubic. You have to convert. So to convert, and we're going to write it here, from centimeter cubic, this is something you should be writing, to decimeter cubic, you are going to divide by 1,000. So let's write here, divide by 1,000. Okay, so it's going to be divided by 1,000. We're going to make it like that on there, and we're going to make like little stick. I want you to be writing in the book in this specific way. So when you go to this page, you'll see that such a sticker popping out quickly, and you are not going to struggle looking for it. So here, when you divide by 1,000, it's 500. Let's do the division here. 500 divided by 1,000 is equal to 0,5 cubic decimeter. It is important. So I will convert in the data. What else we know? We know the concentration is equal to 0,32 mole per cubic decimeters. There we go. That is the concentration. And what we need? We need the number of mole. We always need the number of mole for the reactant, for both of them. Now, according to the data we have here, what formula is the best to use for this number of mole? Well, concentration is equal to number of mole divided by volume. The formula is going to be given to you in this way in the exam. So that's why I'm going to write it in this way. When we substitute, in this case, the concentration is 0,32 equal to the number of mole divided by the volume, which is 0,5. Guys, I do not like to rearrange before I substitute. That is entirely up to you. Okay, so when we rearrange this one, I'm going to rearrange now. We get that the number of mole is equal to 0,32 multiplied by 0,5. I'm going to tell you why I don't like to rearrange this one. I don't like it because they give the mark for this one, and it is like that in the exam, so it is easier to write. Second, they give 1 mark for the substitution without calculation. So if you substitute every number by its variable, then or every variable by its number, then you'll get that mark. And then there is no mark for rearrange. If you rearrange and you make a mistake, then you lose the mark, guys. That is why I don't like to rearrange. So in this case, there is only the answer, and now we have that the amount is 0.16. Let's fix that, 616 mole. So this is the answer we have. Now we don't know yet which one is the limiting reagent. We have the amount of mole that we started, the beginning. Okay, so now what we're going to do, we are going to do the ratio. So we're going to do the ratio of the reactant. In other words, we're going to do Ca to HCl. So it's Ca to HCl. And you can use either of the starting point. Now, what is the ratio? We go back to the equation. The ratio, guys, is the numbers at the front. So the ratios are coming from here, right? This is the ratio. That one and that one there. So the ratio is 1:2. Don't swap places. You have calcium first, let's then write calcium first. 1:2. And then we can use either one of them. So I'm going to use the calcium. If we have 0.0625 mole of calcium, how much hydrochloric acid you will need? And this is a cross product here. Okay? So what we get when we solve this part here, we get that is 1x equal to 2 multiplied by 0.0625, right? And then you get that x is equal to 0.125 mole. Now this one, guys, note this one is for HCl. Of HCl is needed. So that is the question here. Okay, so now we have this one needed for hydrochloric acid, but how much we have? If we go here, we started with HCl. That was the starting point. We only need 0.125. Therefore, the hydrochloric acid is more than enough, and in other words, the hydrochloric acid is in excess. Okay, so this one means that the hydrochloric acid is in excess. Now, by how much is in excess? Okay, by how much in excess? Well, we started with 0.016. We need 0.125. How much will be left behind? Well, the starting, which is 0.16 minus 0.125, is going to give you the leftovers, and that is going to be 0.035 mole. So this is the amount of hydrochloric that is left behind during the reaction, guys. That one is the answer for question A. And it's simple, it's easy peasy, Now, what is the thing? If instead, when you're doing the ratio, if instead of doing this one, so let's come here and say if, and then let's say you use the other ratio. If, for instance, I'm going to say ratio, the same, Ca to HCl, okay? But yet you didn't look, and then you do the ratio, the other one. You say 1:2. Okay, how much calcium do we need if we have, how much is the hydrochloric acid? 0.16 mole of hydrochloric acid is used. How much do you need? You do the same. You do the cross product here. Okay, guys, this is if somebody did in this way. Okay, you do the cross product, and then what you're going to get here is that is 2x equal to 0.16. X is equal to 0.08 mole. So we go here and we ask the question. We need 0.08 mole of calcium. How much we have? we have 0.06. So we have less than what we have. So if you use this method, in actual fact, what you look is for what you identify is the limiting reagent, which is not the hydrochloric acid. Let's move it, sorry there. Let's move it to this, guys, which is the calcium. The calcium is the limiting reagent. Now, what happened? If you do it like this, it's fine. You identify the limiting reagent, but the question is about the excess. So all you have to go is to, when you identify the limiting reagent, you cannot do anything with it. You go straight and you calculate the one that is in excess. So you will have, this is just luck, guys. This is just luck. If you do this one at the beginning and you determine, okay, this one is in excess, end of story. But if you did this way and you instead determine the limiting reagent, then you still have to go back and repeat this process once more. It's quite simple. So that is the answer for A. And then B, calculate the volume of hydrogen produced at STP. Now, the volume of hydrogen, here they're asking you how much of this hydrogen is being produced at STP. So to calculate the product, we always going to use the limiting reagent. Guys, take the notes. To calculate the product, you are always going to use the limiting reagent. So we're going to do B on this side here. I'm going to make like a small space here for question B. It's enough space. This one is for B because we have most of the calculation. So we're going to use the ratio between limiting reagent and product. And this is going to always be like that. So I guess this is an important note you should have. You should be writing the note just now. So the ratio between the limiting reagent, which is calcium, so it's between calcium. I'm going to write here ratio. So let's write ratio between calcium, which is the limiting reagent, and the product, which is H2, hydrogen. Okay, so what is the ratio? You go back to the chemical equation. The ratio is 1 for calcium, 1 for hydrogen. Quite simple. Even though it is simple, do it because you get marked for doing that. So it's 1:1. That is the ratio there. So what is the number of mole of calcium that we have there? You use the one that you started with because it is the limiting reagent, 0.0625. So this one is 0.0625. Therefore, the number of mole for hydrogen is going to be 0.0625 mole. We're looking for volume. What formula can help us to do that? Number of mole is equal to volume divided by molar volume. They say it is at STP. They are telling you that happening at STP. Therefore, the molar volume is 22.4. When you substitute the values here, you get that it's 0.0625 equal to volume divided by the molar volume, which is 22.4. When you rearrange and calculate, guys, you get that the volume that is formed is 1.4. Let's erase this one. 1.4 cubic decimeter. Guys, this is the end of the question. Practice. Question will help you to understand better and solve any question. Stoichiometric calculation is not that bad. Most of them are almost the same. They follow the same steps. So you don't have to learn questions, you rather have to learn steps. But thank you for watching. I hope it helped. If it did, please subscribe for the channel, thumb up. I'll see you next time. You can ask for certain videos if you struggle with some topics at school. I'll see you next time, Mr. G here.